Hi, in this episode of Any Bit Fever Dreams, I'm going to cover how you can add Wi-Fi network functionality to a F256K by adding an ESP8266 Feather Huzzah module sold by Adafruit. Basically letting your funky little Foenix machine connect to stuff online. At the time of making this video, it's still early days, and there's not much to do. However, the Foenix community is rallying around a practice project of creating a multiplayer racing game where hopefully each Foenix machine would have its own client, rendering the state of the game locally. This is all still in the planning phase, and no client or server has been written yet. But the potential to make something fun and engaging in the community cannot be denied. This is where the optional Wi-Fi module obviously comes in to add the ability to connect to this would-be game server and let you play with the others. So I'll be covering the do-it-yourself route for those who have the equipment, time, and skills to solder through all components. I'll be providing links in the description. I'll be going through prepping the module board with a proper firmware for Slip network protocol, then showing my soldering process. I'll follow with the additional enabling steps you need to do on your F256K board, then inside the kernel when it's running, and finally we'll look at a couple of programs to test it out. So the Foenix Wiki might not be exactly perfectly up to date. Instead of browsing the wiki the usual way, just go to special pages, list of all pages there, and the Wi-Fi setup is pretty on point despite the wiki being in general not up to date. But this page is great. It has all the steps, all the links you need. So the first step is going to involve installing the Slip Wi-Fi firmware into your ESP8266. For GitHub projects that involve more than just one executable, I just clone the project completely. I go to code, I copy the URL, and I can use some tool like GitHub for Windows, and I can clone the repository and the URL, just paste the address there, and just get it cloned. Whenever you clone a project, be ready to quickly and easily go to its folder. You can select the Show in Explorer option. The only set of two files you'll need are in the firmware directory. Here you can see a README file with a lot of steps, but you should really follow the wiki, which is better and more concise. So the next step involves going to get your ESP tool, which is the actual program that will send over the data for the new firmware. I just clone the repository again and quickly navigate to the folder which contains it. In order to upload the firmware, I have to assume you've already installed Python 3 as well as pyserial, the module that lets you communicate with serial ports, and there are several ways to go about it. Personally, I use the package manager, which is called Chocolatey, which works great in Windows, but you could also use the binaries to install those. You just have to follow the instructions in their respective web pages. So the command you need to type out to use ESP tool is written there in the wiki, but you have to replace some of the parameters with some of which you will find on your own computer, starting with the port number. To find the COM port used by your Feather when it's plugged with its USB cable, just go to a command window and type mode. You'll see a list of all the serial devices. In my case, it was COM7 at first. Over in the command window, you can read off the Python command using the ESP tool. It actually uses outside folders to access the two bin files for the firmware. I could have quite shortened this if I just copied over those bin files into the folder that contains the Python script. But in any case, I noticed later that my Feather unit seemed to have a 4 megabyte flash memory capacity, and here I'm using the -FS8MB for 8 megabytes. Perhaps this is wrong, and maybe the best course of action here is to just use detect instead of either of those, so it can figure out how big the flash memory capacity is. And then I let the script run, but I encountered a problem. It just refused to connect. It took about 20 to 30 seconds every time, and it would just not accept a connection at all. So I scoured the web and found discussions on this very topic. It sent me to some red herring solutions. It told me to tie some pins in the Feather using a resistor, and it just didn't work. So after a few hours of searching the web for forum discussions on this problem, I found out that the VCP drivers, the Silicon Labs drivers for CP210X, which is responsible for communication between serial and USB, and there's such a chip on the Feather. My drivers were dated from 2007 inside my Windows 10 Family Edition. So as soon as I subbed in the 2023 drivers with the INF files, everything went swimmingly. So I went back to the script and ran it with some cleaned up command line, and for some reason the COM port changed to number 8, and it took about a minute, and it was a success right away. Here I'm going to show the soldering, assembly, and inspection process, and most of the footage will play back sped up. I won't turn this into a tutorial, as this is not a focus of this video. You can find tons of soldering guides across YouTube and elsewhere. You might pick up some of my personal preferences in how I do this. I'm using a temperature-controlled soldering station from Hakko. The task is relatively simple since that is a through-hole soldering job. I use solder material with a rosin core, which could mean that if I pace myself fast enough, I could do it without using additional flux, but I still use that nevertheless because I like to secure my solder joints extra nicely. At any point in this whole process, both jumpers for the UART selection should be switched over from the DB9 wired configuration to wireless slip so that the feather can be actively used. Forget this at your own peril and frustration. Both RXD and TXD jumpers must be changed that way. Okay, the hardware part is almost complete, so let's inspect the work from up close. The board can be put back inside the case and closed up. The last step is to flip two dip switches, but those can be accessed from the outside underneath the machine. I'm going ahead with a good old smoke test to see if there's no critical error in soldering. The last physical hardware step is to flip the dip switches number 3 and 4 to let the kernel know you have a Feather module installed. This next step is probably not necessary unless you're an early adopter like me and got your machine in early 2023. Updating your F256K firmware is going to happen fairly often in these early days. For sure, if you get the 2023.5 firmware release, you will be able to use the Feather. An earlier release probably works as well, but I haven't bothered to check which one is the earliest that allows slip connections. Perhaps they all do. Type out /DOS in superbasic to go to the DOS of the microkernel, and it's a very easy Wi-Fi command followed by your SSID and your password. Very simple. You'd only need to do this once. The first program is a trivial TCP client called game.bin that I send to my machine using the Foenix Manager Python script. I use address 2000 following the lead of Gadget, who wrote it. After hitting return and getting connected, the server just echoes what you type, validating that the TCP connection is working. This is merely a sanity check for your Feather Wi-Fi module. Next up, we have a Mush client, again done by Gadget. This is some kind of multiplayer networked text-based world exploration / creation that can support concurrent players. It is a trip and a half by itself. Feel free to explore fully and use the help function generously to figure out what to do. That about wraps it up for my video. I should mention another great channel for Foenix stuff called Tail Recursive. Over there, Peter also gives a well-rounded tutorial, not showing the soldering but focusing more on the configuration paired with additional instructions for Linux. There's a bunch of troubleshooting tips that he covers as well in some of the steps. If you'd rather not do any amount of manual labor, you can purchase a F256K with the Wi-Fi board already pre-installed and pre-configured for $75 by ticking this box in the order page. This option is fairly recent and has been added this fall season of 2023. Incidentally, at the time of posting this video, there's about 2 days left for a special offer on the F256K where you get exactly $75 off until December 5th, 2023. Please understand that I'm not sponsored by Foenix Retro Systems in any way or have any business affiliation whatsoever. I'm just enthusiastic and want this platform to soar. I hope this video helps you out, and hopefully I can see you out there in a future online multiplayer game running on our F256 machines. Take care and see you next time.